Thank you very much. Thank you for the introduction. Welcome everyone on the stage. Kalimera Thessaloniki. Yeah, nice to meet you. Yeah, okay. I hope so that everything is working. Can you hear me? This is the first question, very important. Okay, thank you. That's very important. Usually, when I just start and remote training on meetings, definitely the first point of the protocol is if we hear each other. If it's fine, that's okay. Go. So, welcome to my talk. It's being called Enums on steroids. And just to be honest to you, this Enums on steroids is a little bit teaser because we are trying to talk more or less about this evolution and new features in Java that has been introduced since version 11 to version 23 even. And I selected these features that are more or less used by the programmers on daily basis. We are not talking about this garbage collector stuff and so on other people who are falling behind your minds on the usual work. Of course, they are also important. I do not neglect them. But let's focus on something which we are really using during the typing. I'm pretty sure that typing the code, of course, in these times, it's more or less more and more rare because usually, as far as I know, during all of the talks, the AI is somehow increasing their power and we are typing less and less, but still we need to type some code. We cannot do anything. We can, at least we need to type the prompt to AI, so you know. Okay, a little bit about me. I'm Marcin Chrost, as I have been introduced by my colleagues. Thank you very much. I came from Poland, where I'm located, and I live since my birth. So I didn't relocated to anyone else. In the city of Katowice, probably almost no one knows where it is located because usually foreigners know only where Kraków and Warsaw are located, maybe Gdańsk, Wrocław, but Katowice is completely forgotten land full of coal mines and steelworks, like something like Ruhrgebiet in Germany or something like that, or Donbass in Ukraine. So nobody is talking. Foreigners are usually not visiting us. That's completely fine for me. Okay, who am I? I'm an IT trainer. I work as a freelancer for a few companies in Poland, especially Bottega IT Mines, which is one of the most recognized training companies, and everyone working there adds 50 points to his respect. Sorry, I was just joking. There's no problem. Okay, if anyone is interested with what I offer and my trainings, you can visit my site at crost.eu. You can also being redirected there when you are cloning the GitHub repo, which I will show at the last slide, because we will be working on the code base which I will introduce later. And during this code base, we will be introducing some new changes. But before we will dive into the Java language and these changes, I want to perform a small survey on this audience, on you. So first question is, who is not related with Java, not working with it at all? Okay, nice. So definitely all you are Java developers. Next question is, who is working with Java 8 and nothing later? Still no one. Nice, definitely. Okay. Oh, I see one hands up. Okay. Sorry for that. Definitely, but you know, still there are some projects. In 2017, I was somehow teased and put into the project where still Java 6 was used. So you know, you can imagine how was my reaction. But I had no choice. I need to work at least 1 year in that project. Sorry, that's our company. Okay. Okay. Who is using Java 11? Ah, a few hands, nice. Java 17, also one. And Java 21, wow, a lot. Okay, maybe I should somehow transition this talk to the newest version of Java, not starting from Java 11, but don't worry about it. Okay, let's beginning from some intro. You see, this is the Java dev watching his pals working with Kotlin. Yeah, and he's looking, my God, they have new funny syntax constructions. They can extend the class, add some methods, and so on. And what I'm doing here, I'm becoming a little bit irrelevant. Who will employ me in the future? I will just need to be living in this carton box because I wouldn't be able to afford for a mortgage installments. Sorry. So, as being said, we are thinking about changing our job, changing our stack technology, forget about Java anymore. But, in my opinion, this decision is definitely too early. And to explain what we can still achieve with this language, let's go for some business case. Because usually during the talk, during the presentation, you need to somehow present some syntax concept and other things along to some business case. And in our case, we will use the case of loan engine. Okay, so what we want to achieve? We will be lending money, this we are the shark, and we will be lending the money to our customer, and he will repay it, of course, with the proper addition to what we have lent to someone. Seems good, pretty well. We don't see any traps. Everything should work good. Of course, there is some risk that we, for example, can lend like this to an unfortunate pair. If someone knows the so Francis installments, this is the one of my favorite traps, exactly used for two money lenders who were just lending money that the people weren't able to repossess, the pound of flesh. But let's not dive deeper in such bloody details. Okay, sorry, it's not this conference. Let's go directly to our model. And our model assumes that we have a customer who comes to our simple booth in a mall, for example, and he requests a small amount of money, or even the big. That's the question: how much and for what period. And the request exactly contains these two things: amount and period of money. Nothing more, nothing else. Exactly this is what we need. Then this request comes to the evaluator part, and this evaluator decides what should we do with this request. Is this guy or girl worth our faith or something like that? Can we borrow her or him the money? You know, we need to decide. There is some business rules engaged here. We will not dive into deeper because it's not the part of this talk. However, it's something like that. The biggest issue we have here is that this evaluator can give us three different results of this evaluation. The first one, very simple, is that we can approve this request and lend this guy or girl money. But to complicate this thing a little bit, we will decide, okay, but we will add the question of amount, because we will be able, okay, he requested for example, 1,000 euros, and we can, after the careful deliberation, say, okay, we can lend you, but only 800, sorry. Nice. The second one is just the pure refusal, but just, you know, in the 21st century, we cannot just say this poor guy, sorry, we cannot go out, but we need to somehow prepare some polite reason why we cannot lend him money. And the third is that we decide the suspension. Okay, we can lend you the money, but you need to fulfill additional requirements, and this is the deadline to do that. Okay, so we have three states. Ouch. It means that unfortunately, we cannot use the simple Boolean here, which would be very nice to model this. So the loan was approved or not, so true, false, no, sorry, this does not work that way. We have three-state Boolean, false, true, and maybe. So how we can model that? So let's step to our code and present some options, step by step, what we can do here. So we decide we need to somehow model these possible outcomes into objects hierarchy, so it would look like here on the slide. So We have the request class. It's a Lombok class, immutable one, because I prefer to use immutable classes in Java. They have a lot of advantages, especially they cannot be spoiled after creation, and they are safe in the multi-threaded environment. So I always opt for that if this is possible. Of course, we need to use the Lombok here, and this Lombok may be a little bit problem because on the one hand, Lombok gives us a lot of flexibility and possibilities when we are writing Java. On the other, it's something like a poison. If you just transition to the new version of JDK, you cannot usually use it until the Lombok is being updated to support it. And I was painfully felt it when I was using Java 21 because I upgraded the JDK, was well happy. I tried to compile the code, bah, doesn't work. You need to work for Lombok. Sorry, 3 extra days. Maybe not too much, but you know, if you want to live on a cutting edge, it's eternity. Sorry. Okay. So we have this request, interface response, which represents all of these 3 states. And we have this class suspension. For example, I didn't present all the classes because the fields will be different, but the idea is the same. And in the class, we have this annotation of Lombok value, especially as a request. So we are tied up to the external library. It may be a little bit problem. If you for example, use this code, for example, in this assuming clean architecture or DDD, in such case, we will be somehow adding some not needed dependencies there. Okay. Go. Evaluator is a very simple class. We have 2 business rules inside it that we are deciding, okay, if you want to lend too much money, we just refuse it. And if this amount is a little bit smaller, but still there is a long period for that, we need something like employee reference. In other cases, we approve the request. However, to be a little bit mean, we somehow round this amount the people want to borrow by to 80% of the initial amount. Sorry. We need to somehow earn our money, and this is the first process. Okay, so these 3 classes on the previous side didn't look too bad, even with Lombok. This is also acceptable, it might be nicely tested. So everything looks fine, but usually this is something like that. If anyone has studied physics or have the knowledge about the thermodynamics, okay. So there is a second rule of thermodynamics, which means that entropy in our world is only increasing. So it's the polite version of we are just adding this rubbish and so on. And the entropy in code exactly is true, and it is appearing in the last class, which class is being used to run this whole application, because we prepare the request, response by the evaluator, and then we need to do something with this response. And it doesn't look good, to be honest, because we need to check what is the class of the response by this instance of, like that. And this is a very nice, I will also name it the Christmas tree of if and else if constructions, which looks very poor, to be honest, and very, very, very unreadable. But this is not the worst part of the code. The worst part here is that. Because if we check that something is the instance of one class, we need to cast it later. And the question is, why? Why? I checked it in this place, so probably I wouldn't to use it as an instance of approval. But this processor say, no, sorry, I need to some exercise a little bit, so give me some additional work. Let me cast in a different command. So, okay, nice. Good. So let's try to improve this code a little bit. This code on this slide is exactly in version of Java 11. So let's move a little bit to Java, as far as I know, 13. So let's get rid of this ugly casting. Now it looks definitely better, because in such situations, we can drop away the casting and do it especially immediately in the instance of. So we have something like that. And this seems much more reasonable, because in such situations, yeah, we are checking this is the instance of approval, we are adding the variable at the end, and we can use it even in the extra expression in switch, but we will go to it later. So we somehow improve this code a little bit. maybe only a little, that's still small, but okay, let's go further. The next step I'm thinking about is our records. Yeah, I talk about the value classes in Lombok, that they verify that are immutable and so on. However, they add this additional dependency to the external library and so on. So in Java 16, we have something like records. A class which is defined with this keyword record and gives us the same thing that gives us Lombok, but on the cost of the very shortened syntax. We just enumerate these members of the record, and the record is being treated as equal to some of its members, more or less. We will go to that later when we are talking about reconstruction, but also gives us the constructor, the getters, which are a little bit different. We will go to it also to another slide, and also allows us to add some validations and so on, but we will omit it for brevity here. And of course, our record can implement interface response, so definitely the hierarchy is still being kept. And this implementation of the interface will be used later, a few slides when we are talking about. Okay, I somehow revealed a little bit that in record we get something almost similar to this data Lombok classes or this plain old Java objects, but it's a small difference. And this difference is being revealed here. We see that when we are using records in Java, we do no more use something like getters. So the JDK guys definitely decided to break up with this to say sacrificed standard of Java beans, which there was always the standard that the accessors should be with the prefix get, mutators should be with prefix set, also including is for Boolean. No, they decided, okay, no, record is just the sum of its members. So in such case, we do not something getters. We just get the member of the record. So you should need this shortened method. Of course, there were initially some troubles with that because usually a lot of frameworks was relying on this bean convention. So for example, Hibernate and Spring initially were troubles with using that, also these Jackson libraries in Spring. But of course, there was the childhood diseases. Now everything is working fine and you can use the records. Especially I recommend them when you, for example, in Spring Boot, you are trying to model these configuration properties, because records can also be nesting one inside each other. It's a very good solution. Okay, but still, even if this nicest with the nicest instance of CAS and so on, the code still doesn't look good. So let's go one step further, because the most important thing that was annoying us was this ugly else-if syntax. So let's go to pattern matching. And in pattern matching, we definitely clean this code a little bit, because in such case, we can just check the type of the class in switch. So we are just making this switch response, and if this is the type of approval, do this one, and if the style of refusal, do something like that. Looks nice. It's very concise construction, gives us a lot of flexibility. There is no more ugly casting and if-elsing, but still it's something that does not look good. We need to improve it a little bit. The thing that really may annoy us a little bit is this break construction, because if we are using this old switch version, we need to think about the break after each branch, because if you forgot it, and usually it is a very often met issue, you can get into real troubles because your code will be executed in more one branch. What can it mean? You probably know. Okay, so let's lift this switch construction also a little bit and go to arrow labels. And with arrow labels, we can write the switch construction in a very concise way, because for the first, we can just use this arrow and open the block of the code. So definitely it's more readable which block of the codes is for each branch. The second thing, which in my opinion is the most advantage of this version of Switch, is this one. If you only had one instruction to being performed inside the switch, you can just use this arrow syntax, write this in one line, and forget about the rest of the world. Nice. But except these two advantages, there is also a third one, very hidden, which is not obvious at the first glance, and this is that one. In Switch, with the arrow syntax and the blocks, you can use the local variables, because every block, every branch is the switch, is being treated as a separate lexical scope. It comes from the fact that why does this cannot work in the old version of Switch? Just because of this break construction, because we cannot assume that the old branch is a lexical scope, because you cannot be 100% sure if you are not going to the second branch. So you need to somehow, the separation between these branches is a little bit fuzzy. In this version of the arrow labels, it's definitely a clear one, and now you have exactly what do you need, and you are very clean and concise. Okay. Still a little bit better, but you can say one thing, okay, you get rid of this if-else construction in the main body of the switch, but you still have this one, if and else, ouch. And we need to somehow handle this, just because of the fact that in the approval scenario still are the sub scenarios being engaged regarding this amount. If we are granted the full one, or unfortunately we are being granted only the limited version and we need to handle it separately. So we need something more to improve this switch construction, and this one are guarded patterns. Guarded patterns is a very interesting part of extending Java language, because as such they are not a big difference, but they are the example of how preview features can be changed when they are being introduced in JDK, because probably you are very conscious about that a lot of new JDK features is being introduced as a preview ones. So they are not available if you do not deliberately decide to turn them on in the separate version of JDK. And also they are not compatible between the JDK versions until they become the permanent one. And these guarded patterns allow us to add additional switch branch, also with this approval pattern matching, but with the extra condition. And the condition is, of course, in our case, is just checking whether this amount is more or less request amount. Okay. And what is more, you can see another thing, how this construction is being done. It's being used by a very simple clausule when, after this naming of this branch. And what is also more important, you can see that you can use these approval variables already in this condition, because Java compiler knows if this has been true, then definitely the approval can be casted to approval class, so we can use that, that's okay. And what was the very interesting part is the when keyword, because initially when this feature was introduced as a preview one, it was just the double ampersand, like in the end Java operator, and it has been changed a little bit further, and in permanent version is using the keyword when. And the question why this has been changed is probably this was developers were somehow messing it up with the end operator, or whether this is the real case or no, I have no idea, but you should be aware of that. Okay, looks better, but still are some things to approve. And now we are finally approaching the main part of this talk, which has been mentioned in the title, which are sealed classes. And what is more important, interfaces also can be sealed. And these two types, two kinds of objects or the classes interfaces in Java can be sealed, which means that we can directly state that only directly enumerated classes or interfaces can inherit from these class and interfaces. Okay, one can say, what does it give to us? Okay, let's go to our example. In our case, we will definitely seal the interface response, and we state that only approval, refusal, and suspension can inherit after it, which makes more sense because we do not expect any other types that will implement the response because we have only 3 possible states. Nice. Okay, so to accomplish that, we are just using the sealed keyword in the interface. Of course, this works exactly the same way when we are talking about classes. And the most important part, we are using the sealed classes on interface is, of course, the classes or interfaces that met our requirements and can inherit that. So there was introduced the third part of the class definition, because initially in Java we have 2, we have something like extends and implements, and in this case we have also added the third clause permits. And in this clause we are introducing which interfaces or classes can inherit. In such case we are classes, so no one else is allowed to implement this interface response. Okay, what did this give to us? Let's look at our ugly switch still. What is the thing that has been changed during, if we treated this interface as a sealed one, is the part which is not so visible on this slide, but because usually is being omitted, but by purpose I added it as a commented one, and this is this part. Because until we sealed our interface, the Java compiler cannot be sure that there is another class that can implement this interface. So if in this switch we do not add this default clause, it complains and does not allow to compile us. It's for our safety, as usual. If you want to get some safety, you need to sacrifice your freedom. Exactly in this case. Sorry. And you can somehow try to negotiate with this compilers. Nobody, I will not implement any other interfaces. Sorry, I don't believe you. You need to somehow convince me. So the way of convince it is to add this sealed modifier. Now the compiler is pretty sure that it cannot do something like, we cannot add another class. Okay, and with that part of code, we can see that this somehow is being very similar to the situations with the old version of Java if we have the enum here, because the response can be one of possible 3 types. Of course, this one adds additional flexibility, and this set of this value is closed, so the situation is very similar. So let's try to somehow compare these 2 things. Enums versus sealed classes. So let's start from enums, and with enums, something like closed set of value. True, yeah, because we define enum, we know which values are being included inside it, so definitely we can use that. With sealed classes, situation is exactly the same. You seal the class or interface, so in such case, you know the direct children that inherit from it. It's completely enough. Of course, the children may still have some child of its own, that's okay, but you know, if you just present this direct child into the switch clause, that's okay for compiler. Yeah, I know that there is no other possibility. Okay, so up to now seems to be the same, but there's one big difference. Enums do not allow you to make polymorphism. each enum, if you define it in Java, unfortunately has the same structure, the same fields, the same functions, and so on. So you cannot be so flexible as you want. But in sealed classes, the situation is completely different because, as you even see in our case, we have 3 sealed classes. Each of them has different fields, different getters. We can also add some methods for that and so on. So looks nice, and definitely we can treat it as an enum on steroids. So this is the second part of the topic of the talk. Okay, should we finish there? Of course, no. At least we still have 10 minutes. And also, the Java does not finish on the sealed classes and enums and the records. So let's go further. Let's go somehow beyond Java 17. Let's go up to Java 20, what was added. So step 7. Let's somehow try to deconstruct our records. Because, as I stated previously, our records are being treated as an equal to its members. So you can always treat a record an equals to the members, so you can replace it safely in such case. And so this comes to the conclusion that if you are using this record type in a switch clause, in a switch branch, you will usually need to get the access to the record members. And in such case, why do we need to bother to somehow deconstruct the record manually? Why do we need to access these fields in this branch? Let's do it, especially in case when we have this switch branch, because if we are, for example, sure that our response is of type amount, this means that definitely we have the record of approval, and we have as an equal its member amount, so you definitely can use it in this switch branch, and you can deconstruct it in this place. So you just can use this amount value immediately after using this branch. There was some questions on one of my previous talk whether this is obligatory, because people were a little bit afraid whether they need to be forced to deconstruct the records. The answer is simply no. You can still use the records as a branch labels. There is no force to do the deconstruction. You are always can be a happy developer not to being forced to do anything. Okay, but this story does not end here, because if we have only one member, it gives us a big advantage. Of course, we have a 2. The situation is a little bit different because now you have saved 2 lines for typing. But the most important moment when this new feature starts to shine is the situations when you have nested records, because you can deconstruct the records and get immediately even the fields of the nested records in this branch, and definitely this saves a lot of typing. And especially this is very nice when you are working with configuration properties in Spring Boot. You can save a lot of effort and burden when you are deconstructing it. So definitely I can recommend this construction. Okay, 6 minutes left. So let's go to the last thing, because everyone can say, okay, Java 21, okay, you presented us everything, okay, we know that. So let's go one step beyond. Of course, there is a simple risk that Java 23 is not a LTS version, unfortunately, but this feature is a permanent one, so you shouldn't be afraid that this would be somehow evicted from the further version of Java and so on, which, of course, if the preview ones, there is a big risk, because I was expecting a lot from string patterns, and of course they have been evicted from Java 23 because the JDK contributors say, okay, we need to rethink about this, sorry, forget it, forget about string templates, or forget about interpolation, sorry, maybe later. I wasn't very happy about it, but So let's go with this code. And you see that in some cases, we may, for example, do not completely need this records part, because it's completely useless. But we still need to somehow introduce the variables and so on. But in Java 23, you can write something like that. Okay, I need to add the case just to satisfy the compiler or do some actions just to print the loan is refused. But completely, I don't need this variable. It's being completely useless for me. So just dear compiler, I add this underscore here. So let's forget about it. That's fine. We can live without that. Okay. What is more, we can not only use this underscore with on the branch, on the label branch, but also when we are deconstructing the records. And if you need only some part of the records being used, and you can safely omit the rest. And the third case, which is also very, in my opinion, very interesting, is the situations when you have some Java clauses like try catch. In the catch of the exception, you can omit the exception if this is not just needed for you because you only want to log something. Something is wrong. Okay, that's nothing for me. I don't need the exception as such because it makes not me any big advantage. Okay, so we have migrated to Java 23, and seems that everything is better than it was previously. So it's time to somehow conclude our journey we have made. And the conclusion is that the new JDK features are still ahead of us. So it's worth to wait for something just has been promised because the Java projects are still active. The Loom is being also being developed. We also send Valhalla and so on. So the potential new features are very promising, and we can wait for that because it seems that it would be better. So if you see that the Java is developing, the new features are being added, you can feel that you are still relevant. So yes, Java can be still sexy. We are still earning money. There is a lot of code of do it, and the construction of this of the syntax and also other features will be added. So don't worry, the job will always wait for us. There is a lot of code to be maintained as a legacy. Sorry, but you can always try to write it to the new version of Java. And if you want to try these features at home, check how does it works and so on, you can always clean the repository, which I invite you to do that. There is also some extra branch there put for the preview features. I didn't present it in the conference because if I recently presented the string templates, I was very how to say it, very negatively surprised, but they are still out there, so we can look how does they look like. And if you have copied this QR code, I would like you to thank you for attention. Evharisto Saloniki, and if there are any questions, I'm here for you. Thank you.